All right, in this video, I want to take a look and talk about what we did this week. It was a lot. We used the tools that we learned in week one, the confidence intervals and the test hypothesis tools, and we kind of expanded what we can do with them. We looked at working with population means and population proportions. In week ones, we compared, I should say compared, we tested and created a confidence interval for a single mean. In week two, we started off by comparing two means. We first talked about the sample size, whether we had a large sample or not, 30 or more. That's our sample size. Both the sample sizes need to be 30 or more. We took a look at the assumptions that were necessary. This was tricky. The assumptions was a real tricky piece here because the assumptions that we use depend upon how and what and a couple different things. For instance, we need random samples. That's always a true statement. We took a look at a couple different techniques for sampling. I mentioned the paired analysis, but we really spent our time looking at the independent analysis. But then even if we knew we were working with independent samples, whether those populations need to be approximately normal, whether the observations needed to have equal variances in those two populations, those weren't always cut and dry. They depended on some other factors, on sample sizes, on how the data looked in the populations. So pay attention to the assumptions. That's a little tricky. Confidence interval interpretations. Remember, we're working with mu1 minus mu2. Our confidence interval interpretations, what we learned is it wasn't so much the numbers on the confidence intervals, it was the signs. You remember when we took a look at intervals that had all positive numbers? In other words, the upper and the lower bounds were positive numbers. How about the ones that were negative numbers? All negative. In both these cases, we were able to determine one of the means was bigger or less than one of the other means. The one where we weren't sure is when we had a negative lower endpoint and a positive upper endpoint. Now, if that makes sense to you, that's great. If not, you got to head back and take a look at those confidence intervals because you missed something there. And then our test hypothesis technique. You need to be able to do the 4 steps, the test statistic, the p-value, the conclusion. That was working with two means, trying to figure out what's the relationship between those two means. Our next analysis was comparing 3 or more means. The assumptions looked a little bit different. We had all the assumptions, I like to say all the assumptions come out to play for 3 or more means: random, independent, approximately normal, equal variances. You should be able to do a test hypothesis, go through the 4 steps. And then the new piece, I guess, here, obviously it's a new analysis, we're comparing 3 or more means, but the newest piece, I think, in my opinion at least, is when you reject H naught, you're not done. We talked about the Bonferroni follow-up work and being able to interpret those results. Taking those pluses and minuses, we don't actually see those for the analysis of variance, the one-way analysis of variance. We get summary results. Remember the homogenized groups portion of the printout? You remember that? Be able to go through and take a look at the Bonferroni multiple comparisons, be able to make heads or tails out of the information you get on a printout. So interpret the results for that follow-up work. So we did that as well. So comparing two means, comparing 3 or more, and then we kind of reset things and said, let's take a look at working with qualitative variables. We looked at a single proportion, and if you look at these notes here, you can see they look pretty similar to what I put on the first page of these notes, didn't I? Differences for a single mean, same kind of idea. Go through and be able to figure out if it's a large sample. It's not 30 or more anymore. Working with proportions, it was n times p and n times q both have to be at least 15. Assumptions, really just need a random sample. That one's pretty easy. Be able to work our confidence intervals. Okay, and I guess I said that wrong. This is really the last part of week one, isn't it? It's not really the first part here. It's the last part of week one when we worked with a single mean. Now we're working with a single proportion. But these are the same pieces. Test hypothesis questions, be able to do it. Be able to work confidence intervals and test hypothesis, whether we're looking at a single mean or a single proportion or comparing two proportions. This compares favorably to comparing two means, doesn't it? Figuring out the sample sizes, still that n times p and n times q, both have to be greater or equal to 15, except now you have two samples. You have sample 1 and sample 2. Be able to state your assumptions. We need random and independent samples. That's really it. Confidence interval interpretation says negative and positive signs come back again. It's exactly the same as what I just finished talking about comparing two means. And then the test hypothesis. 3 or more means leads us to 3 or more proportions. Very similar stuff. Assumptions, test hypothesis, follow-up work. I'm going to present you with various opportunities to do these analyses, and I want to see how you respond. You're going to see questions like this on the exam. Now, one of the things about the proportions, we don't, and you're going to have to go back to this video to see the proportion when you have 3 or more, they don't always say, the null hypothesis doesn't always say that the proportions are equal. That was the null hypothesis that we used all the time when we were working with means. But because we know the proportions can sum to 1 or have to sum to 1, there are other ways of writing this null and alternative. Sometimes this is what we want to check. Sometimes we want to see if P1 is equal to 0.4, P2 is equal to 0.3, and P3 is equal to 0.3. So the individual proportions are specified to numbers, and as long as they sum up to 1, that's fine. In other instances, the proportions are said to be all equal to one another. So go back and review the proportion videos if you have any questions on that. The follow-up work we do here depends how we have the null and the alternative set up in the first part. The assumptions here are kind of crazy too, aren't they? They're the multinomial assumptions. Looks like a binomial, but for multiple, more than 2 outcomes. And so review the assumptions there as well. The other thing to do with 3 or more proportions, there's a two-way study that we looked at as well. I'm probably not going to test you on the two-way study. I wanted to give you that information. So think about the one-way study. That's good enough. But take a look at all that information. We did all that this week. You've had some quizzes, some competency checks that have focused on that information. The quiz you're going to get, the assignment or assessment, I guess it's called, the project, you're going to get to do some of this stuff for me as well. So get to work, and if you have questions, jump on the discussion board. Love to see a lot of questions about what you're having trouble with. Help me to figure out where I need to invest in you guys. So good luck.